Okay, today let's discuss the chapter 8, Analytic Trigonometries. The first section of chapter 8 is inverse sine, inverse cosine, and inverse tangent functions. Okay, so let's recall what is the inverse function. So we have a function. For example, you have a set. It's called the domain of a function. And you have another set. It's called the range of function. Then the map, one-to-one map from f, the one-to-one map f from the domain to the range. What is the inverse? Inverse, you copy the domain and range and exchange the name. And go backward. This is f inverse. Okay, and it means B is fa. You see, A is here. It is mapped to B. It's equivalent to f inverse of B is A. Then apply f inverse, you map B to A. You apply f, you map A to B. So it's a forth back and forth. Okay. Because of this, we have the property. Okay, so this is the first definition and second property. F inverse of f of x is x for all x. You see here, you start from x inside the domain for all x in the domain of f. Okay, and the other way, you can start from B, go to A, and then back to B. So f inverse of x is also equal to x for all x in the domain of f inverse. So you start from this part, you go to the left and back to the right. So that's the basic property. And the third property is that if you have a graph of fx and a graph of f inverse of x, they are symmetric about the line y equal to x. The graphs of f and f inverse are symmetric with respect to y equal to x, the line y equal to x. Symmetric means here, if you have a point here, it's called the AB. And this point, the corresponding point, it has coordinate BA on the graph of y equal to f inverse of x. And if you connect them, this y equal to x line is a perpendicular bisector. Okay, that's a symmetric with respect to the meaning, the geometric meaning of the symmetric with respect to the line y equal to x. Okay, and to define the inverse function, we need there's an important, a crucial property. F here. F is 1-to-1. F has to be a 1-to-1 function. If you do not have a 1-to-1 function, we don't discuss the inverse function. Okay. Then we have our job. What? Sine function is not 1-to-1. So y equal to sine of x from negative infinity to positive infinity is periodic function. It's periodic. Periodic function is never 1-to-1. It's not 1-to-1, right? You see here. It's a wave, up and down, up and down. Here the same thing. Move to the right, move to the left. So even for one value, see horizontal line test, remember the 1-to-1 function has a horizontal line test. It is 1-to-1 if and only if all the horizontal lines intersect the graph of function at most one point. Vertical line test if the curve is a graph of certain function. Okay, so it's not 1-to-1. So we have problems. So in general, there's no inverse function for sine. In general. If you just say, let's say, we look for the inverse function for sine, there's no, because it's not 1-to-1. But the sine function is such important function, so we do want to construct, artificially construct some inverse function. So what do? We do not pick up all the sine function. We only pick up part of it. We need to restrict ourselves to a domain so that the function is 1-to-1. We observe that, we find from here to here, from negative half 2 to positive half 2. In this domain, the sine function is 1-to-1. Okay, so we are going to define the inverse function for the sine function with this specific domain. Okay, so we just define the inverse sine for this domain, for the sine function over this domain. Okay, so let's see definition. We define y equal to sine inverse of x. It means x is sine level y. It's a definition of an inverse function. Why is it sine inverse of x? You move this. It's kind of you move this function to the left side. When you move to the left side, you change the inverse to the original function. Where? Okay, so the x is in the domain of sine inverse. It's in the range of sine. X is in the range of sine. The range of sine, the range of sine is between -1 and +1. And y is in the range of sine inverse, but y is in the domain of sine. We only discuss this domain. This is a domain. the range of the inverse is the domain of the original function. Okay? And let's see. So that's a definition. That is a definition of a inverse sine. And what is a graph of inverse sine? We're going to use a symmetry to quickly to quickly access it. So you have a check here. You have a pi over 2. Pi over 2 is 1.5, so it's a slightly bigger because the range of sine is -1 to +1. It's a pi over 2, negative pi over 2. So the sine function is a little bit flat, horizontal. It must pass through the origin. And then you draw the tangent line. Sorry, not tangent line. The line y equal to x, not tangent. You don't know it is tangent line so far. Okay. Then you're trying to find the symmetric point with a symmetric image with respect to the y equal to x. So this point, the x coordinate is pi over 2, y coordinate is 1. This point, the x coordinate is negative pi over 2, y coordinate is -1. Okay. So when you get the symmetric point, you see you switch the pi over 2 and a 1, you get a 1 pi over 2. So you got 1 pi over 2. Sorry, yeah, it's hard to sketch. And here you will get -1 negative pi over 2. So if you try to sketch it, it looks like this. It's more vertical. The red curve is more vertical. The horizontal curve is the sine function. This red vertical curve, sine inverse function. The sine inverse function. Okay, so this is the graph. It's a vertical curve. Something like this. And from here you can see that it has several special points. So here you have a 1 pi over 2, -1, negative pi over 2, and 0, 0. So far we have those 3 special values. Once you have a function, you need to know some special values. To get a special value of an inverse function, we always start from the special value of the original function. Okay, so let's see what is a sine function. Sine function, this way. So we always start from the angles in the first quadrant. 0, pi 6, pi 4, pi 3, pi 2. And for the sine, you have 0, half, √2 over 2, √3 over 2. I will put the sign someplace. And 1, 1. 1 is a √4 over 2. 1 is √4 over 2. And if you extend it to the right, which we don't need, but if you extend it to the right, let's see, how do we extend? Here you have 6, 4, 3, 2. And then you will also have, you will get symmetrically 3, 4, 6, and pi, of course, and pi. And of course, this is part of 2 pi, and 3 pi, and 5 pi. Okay? So that's the way we know what is the next angle. And then what's the value? So you go up and you go down. So increasing and decreasing. So you get √3 over 2, √2 over 2, 1/2, and 0. So today we don't need this part because they are not in the domain. they're not in domain. And we need the left part. Our domain of sine is negative half and positive half 2. So sine is an odd function. Remember, sine negative x is negative sine of x. It's an odd function. So when you put here, you get a negative half of 6, negative pi over 4, negative pi over 3, negative pi over 2. For negative input, you get a negative output. Negative input, you get a negative output, respectively. Okay, so you see here how we get this part and this part based on the angles in the first quadrant. And let's put here is the angle theta, here is sine theta. Okay, so for the sine inverse or inverse sine, so we need this table because they are in the domain. Okay, so you need to know, or at least to keep this in mind, this little table. And then let's see the example. Find or evaluate sine inverse of 1. Sine inverse of 1. This is an angle. It's an angle. Although it's even though it's a value, it's a number, but it's an angle. It's a reading. No, it's a reading. Okay, so we choose theta to represent this angle. Then by the definition of a sine inverse, theta is sine inverse of 1, then sine theta is equal to 1. You move this symbol to the left side, you change the sine inverse to be the sine. Okay, sine theta is 1. You read this little table, you see only pi over 2 give you sine theta equal to 1. So theta is pi over 2. And that's it. And that's it. Of course, if you don't start from this definition, you only start from sine theta equal to 1 without any consideration in the inverse, theta is not unique. It's periodic plus any 2k pi, you will get the sine theta equal to 1. But our theta is from the inverse sine, so it's always between the negative half 2 and the positive half 2. Okay. Okay, and similarly, if we want to find another value, sine inverse of a negative pi half, so you will do the similar stuff. Let the theta be sine inverse of negative pi half, and then theta is a sine inverse of negative pi half. Then sine theta is negative, no pi half, sine negative 1 half. Theta is sine inverse of negative 1 half. Then sine theta is negative 1 half. So here, theta is negative pi over 6. Okay, so for us, we only memorize this little table for the exact value of sine inverse function. Any other value depend on the calculator or more advanced tools, which we don't require. Okay, so let's check. Sine inverse, they are a pair of inverse functions. So we do have property. Property 1. Sine inverse sine of x is if x is between negative pi over 2 and positive pi over 2. Okay, so if it's in the domain of a sine function, in the definition of a inverse trig, so we have to keep this x between these, then you have sine inverse sine is equal to x. And second, sine of sine inverse of x is equal to x if x is between negative 1 and positive 1. This is the domain of a sine inverse. Okay, this is the domain of sine inverse. Okay, so this way we have sine, this way we have sine inverse. Okay, so let's check the examples based on this property. Sine inverse of sine of pi over 8. First check this pi over 8. Pi over 8 is between negative pi over 2 and positive pi over 2. So when it is in the domain, by the definition, it's a pi over 8. Okay? So this is the straightforward application. Now let's see something which is less straightforward. Less straightforward. Okay. Sine inverse of sine of 5 pi over 8. Five pi over 8. 4 pi over 8 is pi half. 5 pi over 8 is someplace here. It's outside of a negative pi over 2 and positive pi over 2. Okay. Okay, then what is this? If it's outside of the domain, so you are looking for an angle. Theta. You're looking for angle theta. This angle theta give you the same sine value between the domain negative half to inside domain negative half and positive half 2. So how do we get a value sine 5 pi over 8 equal to sine theta? You draw the horizontal line, not tangent, sorry. You draw the horizontal line, intersect the sine at 2 points. Intersect the sine at 2 points. So you will see this intersection point and this intersection point. And this is the angle theta. This is angle theta. Okay? So the angle theta is on the left hand side of pi over 2 in the domain. This is unique. There's only one. And this is determined by the reference number, reference angle. Remember that this is a 5 pi over 8. Its reference angle is a 3 pi over 8. The reference angle has a sign either same value or with a negative sign, with different sign. And here, you check the relative position. You know that the theta is share the same value of 5 pi over 8. Sine 3 pi over 8 is equal to sine 5 pi over 8. because it's in the second quadrant. Second quadrant, remember, A, S, T, C. All the trig values are positive. Sine is positive, tangent positive, cosine is positive, right? A, S, T, C. Okay, so once you figure out what theta you have, then the sine inverse of sine 5 pi over 8. So first you write it like sine inverse of sine 3 pi over 8. And then, because 3 pi over 8 is between negative pi over 2 and positive pi over 2. Good, 3 pi over 8. So here I actually present two ways to determine this value. Either you can use this horizontal line to cut the graph and determine the theta. In this place, this pi over 2 is a midpoint. In other words, this and this, they have the same length, the symmetric. So the 5 pi over 8 minus pi over 2 is equal to pi over 2 minus theta. They share the same distance, share same length. So you can also solve for 3 pi over 8 from this equation. Or you can use the reference angle. Either works. Okay. Okay, after we figure out the inverse sine, let's see the inverse cosine. The inverse cosine you see, if we still choose the domain negative pi over 2 and positive pi over 2, the function is not one-to-one. It's up and down, it's not one-to-one. In the cosine version, we're going to select the domain from 0 to pi. We select only this part from the 0 to pi. It's a decreasing function part. This is not useful. And for this one, we define y is equal to cosine inverse of x. Means x is cosine of y. Here, x is between negative 1 and positive 1, and y is between 0 and pi. Y is between 0 and pi. Okay, so this is the cosine inverse, and the graph of cosine inverse. You imagine what it is. It looks not that trivial, so it looks like this. It's a decreasing function. It looks like that. This is a pi. It's pi over 2. The intersection with the y-axis is pi over 2. That's negative 1. This is positive 1. Here there's the intersection point. Okay. So this is a graph of a cosine function. It's a decreasing. By the way, the sine inverse is an odd function. Cosine inverse is not odd because its domain is not even symmetric. The domain is not symmetric. So, sorry, for the domain it is cosine. This selection is not odd, but cosine inverse is not odd either. The the domain is symmetric, but it's not even not odd. This domain is not symmetric, so the corresponding range is not symmetric. Okay, so this is a graph of a cosine inverse. And similar thing, let's recall the values of a cosine. We will also start from 0, pi 6, pi 4, pi 3, pi 2, and then remember that 3, 4, 6, and the pi. Here's 2 pi. How do I get 2? 3 minus 1 is 2. 4 minus 1, 3. 6 minus 1, 5. Okay, and this time we use this bound, this part. And for this part, if you want, you can copy. But remember that the cosine is an even function. So this part, the left, if you move to the left, is just repeat. So you get 1 root 3 over 2, root 2 over 2, 1/2, and 0. Here is symmetric. So root 3 over 2, root 2 over 2, 1/2, and 0. And this part, you're going to copy this sequence 1/2 root 2 over 2, root 3 over 2, and 1, but they are all negative. And this is a theta and a cosine theta. For the inverse study, so we need this table. We need this table. Okay, so let's check the example. The cosine inverse of 0. So if we call it theta, again this is an angle. If we call it theta, then cosine theta is 0. So check this table. Cosine, the value should be 0. So the corresponding theta is pi over 2. The corresponding theta. And similarly, if we want to find the cosine inverse of a negative root 2 over 2, you set it to be theta, then cosine theta is negative root 2 over 2. So you check here, check this second line. You get negative root 2 over 2. The corresponding angle is theta. The corresponding angle is theta. Okay, so the same property but here if x is between 0 and pi, it has to be in the domain of a cosine. And second is if x is in the domain of a cosine inverse. Okay, so let's check. The sine inverse, cosine inverse, they have a lot of similar examples. So for example, if we have cosine inverse of cosine pi over 12, okay, so this angle is between 0 and pi, and this gave us pi over 12. Well, we may not, this is so trivial, so possibly we will not include this in the exam. We will include the example with a tiny computation. And cosine inverse of a negative 0.4. Negative 0.4 is between negative 1 and positive 1, so this is negative 0.4. If you see cosine inverse of negative 2, negative 2 is not inside it. and this is undefined. It's not inside the domain of a cosine inverse, so it's undefined. Whenever I have a cosine inverse of -2, -10, -pi, yeah, here. This is also undefined. Don't be tricked. Don't be fooled by this pi. Pi is a 3 stuff, so -3 cosine inverse of -3 is never defined. And cosine inverse of cosine -2 pi/3. Okay, so So first of all, -2 pi/3 is not in the domain 0 pi, so you cannot apply it directly. There's no way to apply it directly. And so in order to, so we're going to get the similar step. We're going to draw the horizontal line to cut the graph and find a corresponding point so that they are on the same horizontal line. They have the same value. And from here you see it is symmetrical. Well, my sketch is worse. It's horrible. But you see that this is a very symmetric part. This is -2 pi/3. This is positive 2 pi/3. And another way to find this value is that cosine is an even function. You don't need this negative sign. You have or you don't have negative sign. Doesn't change the cosine value. Right? Cosine is inverse. Cosine is an even function. It can kill the negative sign. Cosine is an even function. So this case, this time the 2 pi/3 is between 0 and pi. 2 pi/3 is between that. Then it is equal to 2 pi/3. Okay, so for whatever stuff, you must find the corresponding point inside the domain 0 pi for cosine, -pi/2 to +pi/2 for sine. Okay, and you can also use the reference angle to compute. This one possibly reference angle is not the best way, because we just use the even function property. We can quickly kill this negative sign, because this time the reference angle is this pi/3. Pi/3 is negative. Cosine pi/3 is negative cosine -2 pi/3. In the third quadrant, the cosine is negative, so you have negative sign. Yeah, so it's bad. We use even property, cosine even function. Okay. We studied the inverse sine, inverse cosine. Let's study the inverse tangent. Tangent function is like this, has a graph. So tangent function naturally has a lot of branches. So you just pick up one branch. All the branches are identical. So we will just naturally pick up the branch, the middle branch. Or when we say the middle, we mean the branch containing 0. Okay, so we have the definition. Y is tangent inverse of x means x is tangent of y. Where? You see, this is domain of a tangent domain. Y is between negative power 2 and positive power 2. This place, be careful, it's an open domain. It does not include negative power 2 and positive power 2. And x is in the range of y, negative infinity to positive infinity, which means x can be whatever value. Okay? And the graph. Okay, power 2, negative power 2, and the graph of tangent is like this. And if you check the symmetric curve, so first you symmetrically draw the horizontal power 2 and the negative power 2. If you want to get the it looks bad, sorry. It's like this. So it's a smoothly going up, approaches power 2. To the left approaches negative power 2. So it's this curve. This is a y equal to tangent inverse of x. The beautiful graph is on page 611. You can, if you want, you can read the book and find a better graph. For the tangent, we also labeled. Place the small evaluation table. So we have a 0, pi over 6, pi over 4, pi over 3, and this time there's no pi over 2. There's no pi over 2, and negative. And there's no negative power 2. Okay, so you have 0, root 3 over 3, 1, root 3. And here you symmetrically negative. Because the tangent function is a negative. It's an odd function. If you put pi over 2, this is positive infinity. If you put a negative pi over 2, it's negative infinity, undefined. So basically we say that undefined. Okay, so you memorize this table, then you have the similar examples. We do the evaluation. So what is a tangent inverse of 1? What is a tangent inverse of 1? You set it equal to theta, so tangent theta is equal to 1. So you read this table, theta is equal to 1. So tangent theta is equal to 1, theta is pi over 4. Okay? And if you want to get tangent inverse of negative root 3, you get negative root 3 here, then theta is a negative pi over 3. Theta is negative pi over 3. Okay, so whenever we have the table, it's an easy job. It's much easier. And by the way, tangent inverse is an odd function. Sine inverse is an odd function. Cosine inverse is not even, not odd. Okay? So keep this in mind. It's an odd function. For the tangent inverse, tangent pair, you also have the same property. Tangent inverse of a tangent of x is equal to x if x is in the domain, in our domain. Then second, tangent of tangent inverse of x is equal to x. Here x has no restriction. Technically, x has no restriction. Be careful. For the second property, let's recall. For these similar corresponding properties, x are both between negative and positive 1, because this is in the range of cosine. You see here, cosine stuff is equal to x. X is in the range of cosine. X is in the range of sine. So x can only be between negative 1 and positive 1. Any number outside of that will be undefined. But for tangent, x is in the range of tangent. Tangent has a range negative infinity to positive infinity. No limit. Okay, so that's the advantage of tangent inverse. Okay, so let's see the example. Okay, so find the inverse of fx is equal to 2 sine x minus 1. Here x is between negative half of 2 and positive half of 2. Find the domain range. Find the domain and the range of the inverse function. Okay, so how do we do that? We just let y is a 2 sine x minus 1. Then we are going to solve x in terms of y. So we move 1 to the left side. We divide the equation by 2 by the coefficient. And we know that this is an advantage. Sine x is between negative half 2 and positive half 2. It's exactly the setting in the definition of sine inverse. So you find the inverse up to this step, it is still the original equation. So this equation, even though they look different, but these two equations are the same. Then we must do this step, exchange x and y. If we exchange x and y, x becomes y, y becomes x. This is the inverse function. Before you exchange x and y, it is still the original function. You just transform it to a different formula. Okay, so this is the inverse. And let's check the origin. Okay, so we finished the we finished the first part, find the inverse. And second part, find the domain and the range. The domain, the range of the inverse is the domain. This is F inverse. the range of F inverse is equal to the domain of F. The domain of F, negative half 2, positive half 2. That's simple. So this part you don't need to compute. And the domain of F inverse is equal to the range of F. Now we have to study it. X between negative half 2 to positive half 2. Sin x is between negative 1 and positive 1. 2 sin x. 2 sin x is between negative 2 and positive 2. You just multiply it by 2. You get a negative 2, positive 2. And minus 1. 2 sin x minus 1. You subtract 1 from here, here, and here. All three part. You get a negative 3 and a 1. So the domain of F inverse is equal to the range of F is equal to the closed interval negative 3 and 1. Okay, so that's a way to find the domain of the range. The last example. Solve 3 sine inverse of x is equal to pi. Solve this equation. Well, how do we solve it? We'll just go step by step and simplify it. We divide the equation by the coefficient. Sine inverse of x is pi over 3. And then we apply the definition of the sine inverse. Sine inverse, you move this symbol to the right. This is F inverse. If you move to the right, it becomes F. Sine pi over 3 is root 3 over 2. So x is root 3 over 2. So the solution is square root of 3 over 2. Okay, so this is the section 8.1, the introduction of a inverse sine, inverse cosine, and inverse tangent. Okay, so you just do your corresponding exercise and make sure you understand the basic concept. Okay, thank you very much. We'll stop here.